care about Aaron. He doesn't care about me, obviously. He didn't care about Elias. He didn't show up to his thing yesterday. Huh?
He Venmo'd me a consolation $5.
Oh my God, dude. That's what you're worth, huh? $5. Wow. Man, he's a thousandaire now, and he can only give you $5. Okay. There were a lot of model adjustments, okay? There's a lot of them. Most of you got most of them, okay? There were some small ones. I think you could tell, definitely, those of you that were methodical in the way that you approached going through the model, you had a higher success rate of finding everything, right? Like starting out with just the layouts, right? The first floor level was a foot short, right? And then there was a frame that was a foot in the wrong direction, stuff like that. Like all of those little things, if you just start and be systematic with it, I think you had a higher success rate of going through everything from layout to loading, materials, framing sizes, all of those things, okay? So there was a lot of them. We don't need to go through all of those. Model description, okay? Some of you, I don't know if you thought that the description of all of the changes was the model description. What I really asked for, and it was, I think, very clearly laid out in the question was, okay, now that you have this nice running model, I want you to describe it to me like I gave the examples in class and we talked about in class in the notes, right? And so out of this model description, I took points off where this 1 sheet, 2 sheet, 3 sheet, whatever it ended up being, really needs to lay out everything required for somebody to reproduce your model or understand what the intent of the model is, what the elements are made out of, kind of all of those things. And a lot of you coupled it with the problem statement, which was fine, right? There was a lot of description on the sizes and things. You didn't need to reiterate that. But when it came down to like how you fixed all of your nodes, how you spread out load, right? Your earthquake load distributed to frame lines, lateral force resisting system based on the trig width to adjacent lateral force resisting systems, assumes uniform mass distribution over the building, right? How did you assume things were distributed? I know that I put it in there as line loads, and maybe some of you agreed with that, but you never really described why that would be that way, right? So having something here that really, if you were to take this within your firm or send it to a third-party reviewer, they can say, oh, they made a model, because they're not going to see your model at all. They're just going to see all these results, and they need to feel warm and fuzzy about the way in which you developed this model, right? How you decided members were oriented, how boundary conditions were imposed, how loads were spread out, and so on. So that was a big part of it. Service level, okay? I think for the most part, everyone really did this. The intent here was to try and get you to step back all the way back to where we have our applied loading, right? Dead load was 60 pounds per square foot on floors, 15 on the roof. And you step back and say, okay, globally, I have this square footage of area, okay? If you went and you took the line loads, right, or the loads that you imposed in your model, and you just added all those up, you're really not giving yourself a very good check of your model, because you're essentially using your model to check the model, right? I wanted you to step back even further and say, okay, I have my uniform load. I know the area over which it acts based on the layouts of the building. I can check a global, like service level, that was the other big thing, service level loading, okay? So obviously dead, live, snow, those are all at service level. Well, wind and seismic are not at service level, okay? Do not make that mistake in the real world, okay? That's why I took points off, because I know it probably doesn't matter. You could have related strength level to strength level, right? But I wanted you to realize the fact again that wind and seismic are all developed at strength level. And if you're looking at service level loads, you need to factor those two load sources in order to get there, okay? That is very important.
So service level, dead, live, and snow, like, I figured that those also need, you can't just add all those together. Dead, you can't just do it full dead, full live, full snow. You gotta.
Well, so I like the description was, what is the service level? Nice.
Sorry, I had a slab inspection.
Emergency, cool.
Giving anything out?
Maybe, yeah, go take a seat. So I asked for verify the following results from your VA model using service level load. So it's global horizontal east or earthquake and wind reactions, global dead load, live load, and snow load reactions. So I just wanted you to take the service level dead loads, right, and check the reactions for those. So I wanted you to step back and look at, okay, I've got 60 pounds per square foot. It's acting over a certain amount of area. I've got 15 PSF area. I can figure out what the overall load that should be on the structure should be just based on stepping back and running a quick hand count and then checking the reactions. Or you could go through the statics check is really where that came from to figure out what those were.
But to like add those service level.
The
factors.
ASD load combinations, those, that was not the intent. The intent was to look at, I mean,
Would it be,
it would be a very similar check because you can factor them, right? And then come up with a result and then check that back. But I wanted a check for each one, like dead load, live load, snow load, earthquake, and wind, right? Instead of just taking one ASD factored combination and then checking that.
the same thing,
Could
right?
be.
It is a method to do
never-
it.
Yeah,
If
that would
you're
never
off,
be
you
different.
know what,
Or you would still be, if you would.
No,
still
you could
catch
check it,
and
yeah, I
say,
mean, because you essentially calculated what this was and then you factored it, right? And you did a combination for it, and then you checked that versus what the combination is to be. Yes, it's a similar check, but what this affords you to do is say, do I have a problem in dead load? Do I have a problem in live load? Do I have a problem in snow load?
Oh, sure.
Where if you ran a combination, you say, well, I got something fucked up and it might be dead load, live load, snow load, I have no idea.
You get the perfect storm and it comes out and it's the same, but it's not the same.
Yes, it could be, right? That is a very good point. Yes.
So service level for like earthquake and wind are the factored common, like factored.
Yeah,
like
which is
0.6.
kind of counterintuitive, but
So then in VA, when you go to like, so you do like 0.6 wind, figure out your reaction that you should have, but then to check in VA, do you have to make a custom combination?
no, yeah, so what they do is you can do, like, click a tab, which is the deflection check, and in the deflection check, they take and they do 0.6 W, and they'll do 0.7 B.
So they do that in like selection.
Yeah, so like, well, if you look at, because when you do deflections, you check at service level.
Yeah.
And so in VA, when you click on the load combinations tab, right, it brings up this thing, and I think it's really misleading. I wanted to bring it up to Adam. Like, they call out dead wind, they're dead, snow, wind, earthquake as your service cases. But in reality, the earthquake and wind loads that are in the service cases in VA are actually at strength level. And so when you do the load combinations tab, and then you can like click on LRFD 16, all of the different types of combinations. In there, there's one that says strength, or sorry, not strength, but deflection checks. And in there, that's where you can get VA to do it.
but do you wanna get wind to that matter
What's that?
for that deflection?
There should be,
The deflection.
earthquake
check-
is not in there?
Well, the deflection check doesn't factor them, it still just does one. The deflection, like strength check one does the factored wind, but I don't think it has factored earthquake in there, it just does
Okay.
wind.
That-
So you have to use an ASD combo to get.
The
earthquake.
0.7
Or you
E.
could just use
Or
the
you,
full and then multiply both. by
or you
0.6.
just take, or you could do the static check like I did, multiply it by 0.6.
Just whatever's in VA multiplied.
Yeah, because whatever load combination you have VA giving you, whether it's E or W, those are
Yeah.
strength level, you would just use the appropriate values.
So when you're designing a building, like if you're designing shear walls for like a earthquake load, you wouldn't design it for 0.7 earthquake?
No, you would design it for the full earthquake, but then when you are looking at, like, when you were looking at, say, designing the foundations underneath that shear wall, usually when you check foundations, you do ASD load combinations, and then they use service level demands.
Really? Foundations are specific?
Usually, yeah, it's weird. When you're doing like global foundation check, not strength checks for foundations, like the strength of your concrete pier or your concrete footing, but when like foundational checks, and I don't know if Greg has talked in like or in the geotech, it's like there's slide. You got to check your building so it doesn't slide along the ground. You got to check your building so it doesn't overturn. You got to check your building for allowable bearing pressures, right? And so all of those things you look at from a allowable stress design, because when I was gonna show you a geotech report either today or Monday, but they give you allowable bearing pressures, right? And so there's a factor of safety built into the value they give you, and it's at a ASD load combination level. Yes.
Do you have to apply overstrength when you're checking on soils? Like, when does overstrength stop?
Overstrength stops.
At anchor bolts?
We always did that, like the physical bolt themselves, like getting the anchorage. Like if I can get the load into the foundations, then at that point, then I'm gonna let it go. Is usually what our approach was. Is that your approach, Sutton?
Yeah, and also for soil, like overstrength's usually like, it's not like a long duration load.
Yeah.
Soils can have a huge resistance for a short duration load,
Yeah.
like you can bump your allowable stresses way up.
Yep.
it's-
And even when you're
That's just gonna
checking
happen
like,
once in a while, soil's more like overall, long-term.
yeah, settlement is the biggest issue.
And if you're a schmuck and you still use ASD for your lateral systems, you can still use your 0.7, your 0.6.
Yes, in the design of it.
Words,
Yep,
with
yep,
ASD.
you totally could, yep, if you're like old school.
Yeah.
Is that what you guys were talking about?
Sorry, I was getting stressed out because I remember the spreadsheet at DCI, I swear,
It does.
designing shear walls, but they're wood shear walls.
Yeah.
You multiply by
Yes.
0.6.
Yes, because wood
He's
is
talking
typically
LRFD.
designed in
That's what
ASD.
he said.
They don't have an LRFD.
And same with masonry, if you're doing masonry shear walls, those are the same
Okay.
thing.
And sometimes steel.
Because it's the whole, like, it's the whole demand's gotta be less than or equal to capacity. And with ASD, all you're doing is you're reducing your capacity by a factor of safety. So you're only manipulating one side of the equation. Where LRFD, you manipulate both. You're factoring up your loads to account for unknowns and uncertainties in the load derivation, and then you're reducing your capacities, right? And we do that with fee factors, like in concrete, right? Or in steel.
I want you and Tom to get a beer together and just argue about which one's better.
Well,
think
I
that'd be hilarious.
would do ASD when I did like industrial stuff sometimes, just because in that industry, a lot of the old timers, they like the ASD, and so you can like have a discussion on a common plane, because I would give them a load and they're like, yo, you're fucking crazy. I'm like, well, that's strength level. If I multiply it by 0.6, oh yeah, now we're at 20 pounds per square foot for wind, right? And so like there's this feeling, and that load is more or less what we really expect something to carry, right? When we're doing ASD, because we're just taking the actual loads that are happening, right? Dead load, live load, snow load, and we're not amplifying them. And so when we say that the snow load's 40 pounds per square foot, that's the demand we put on a structure. But then on the backside, when we give it the capacity, we're reducing the capacity of it with a factor of safety. But both design methodologies are very similar. They're just either reducing capacity